state that electrons are distributed singly into degenerate orbitals. Don't forget. Into what? Degenerate what? Orbitals. Or what? Orbitals. I said degenerate orbitals, they are orbitals of the same energy what? Level. And these degenerate orbitals comprise of three what? Orbitals, which is what? SPD. S? No. Which is what? P, D, F. So orbitals of the same energy level are called degenerate orbital and what? P, D, F. Or they are orbitals that have what? More than one subcell. They are called degenerate orbital. P, D, F. So the also now say that what? Electrons are distributed singly into degenerate orbitals before pairing commence. That's also. He said during atomic configuration, the orbitals of degenerate orbital must be filled singly before what? Pairing commence. That is what Unsworth. Unsworth. Let us look at what Unsworth said. He said in degenerate what? Orbitals. Okay. Let me take this as a case of what? Study. Electronic configuration for nitrogen. See it now. Nitrogen is what? Atomic number 7. It's 1s2, 2s2, 2p what? 2p3. So let us draw the shell for what? For nitrogen here. This is this. This here we have what? 3. Which is what? 1, 2, 3. Good. So how many electrons do we have in 1s? It's 2 electrons. Here put it there. 1, 2. This place 1, 2. Good. In this P, we have 3. Abi? I say what? 1, 2, 3. If you do it in this way, you are in trouble. Because this P is what? Degenerate orbitals. It has more than what? One subshell. So you must be what? Distribute the what? The remaining electron to the 3 subcell here. If the electron now remain, you start afresh again. But if you do it like this, you are what? You are in trouble. You don't follow the Ohm's rule. So you need to what? To run everything up. So in that sense, what? 3 remain here, 1 here, 1 here, then the 1 here. Yes, this one follow what? On true. That's how also said was what? We should do it. Okay, if we check another one, let us look at what? Let me take oxygen. Oxygen is what? Atomic number what? 8. By writing it, we have 1s2, 2s2, 2p4. So let us draw this thing for oxygen. Let us look at what? How are we go by apply what? Unscrew. So if we apply unscrew here, what are we going to have? Now let's put what? 1 here, 2, 1, 2. They are not degenerate orbital. Give me 4 here, Abi. Let's say 1, 2, 3, 4. Is this right? If you do it like this, you are what? You are in trouble. You must what? This is P. For PD orbitals, PDF orbitals, you must distribute these 4 electrons singly. First, if it's not remaining, you start afresh again. Please don't do it in this form. So you say what? 1, 2, 3. Remain what? 1. You now put it here. So let me put 2 more examples. Let us look at what? I put 2 more examples. Let us look at fluorine. Fluorine is what? Atomic number what? 9, which is what? 1s2, 2s2, 2p what? 5. By drawing the what? The shell. One, two. Abi? Yeah. In this fluorine, let us check it now. We have 1, 2, 3, 4. Yeah, we have 5, Abi. 1, 2, 3. Remain 2. 1, 2. Yes, you follow on through like that. Let's do it for the last one, which is neon. Look at neon is what? Is 10. Where we have what? 1s2, 2s2, 2p what? 6. So for the neon, we have what? 1s2, where we have 1, 2, 3, 4. This, yes. That's how we use what? Unsure. So the next thing is what? We have 3 application of what? Of unsure. Number 1, we can use unsure to determine the number of what? Unpaired electron. First application uses of unsure, we can use to what? To determine number of what? Unpaired electron in an atom. Look at this now. We apply unsure here. How many unpaired electron can be found in nitrogen? Look at this P. How many? 1, 2, 3. So the nitrogen has what? 3 what? 3 unpaired what? 3 on nitrogen. It has what? 3 unpaired what? It has 3 unpaired 11 what? Electron. So how many unpaired electron we have in oxygen? Is what? 1, 2. So oxygen have what? 2 what? 2 unpaired electron. How many unpaired electron we have in fluorine? We have 1 what? Unpaired what? Unpaired 1 unpaired 11 what? Electron. So if hydrogen want to react with what? With nitrogen. That's why with 3 atoms of hydrogen will react with what? Nitrogen. That is why we have NH what? 3 in ammonia. So this oxygen require what? 2 atoms of what? Hydrogen. That we always have what? H2O. This fluorine needs what? 1 unpair. That we have what? HF. And oxygen is always what? 2 minus. Because it need what? And then nitrogen can also what? 3 minus. It need what? We can also have hydrogen as what? 1 minus. 1 unpaired, 3 unpaired, 2 what? Unpaired electron. The second function of what? Of or the second application of what? Of unsure is what? You can unsure to determine paramagnetic element. Para what? Paramagnetic what? Element. Paramagnetic what? What? Element. What is paramagnetic element? Any element that what? They are partially fill the degenerate orbitals. Any element that is what? Is electron is partially fill what? The degenerate what? Degenerate orbital are called paramagnetic element. We have P, D, F. If the electron of the element is partially fill what? Either P or D or F are called paramagnetic element. Is one of the what unique feature of what of transition elements. Transition elements, they are paramagnetic elements. They are partially filled what the D orbital. So yeah, look at what these 3 elements now. Which of the 4 elements here are paramagnetic? Look at nitrogen. It's partially filled what? P. Oxygen partially filled what? P. Fluorine partially filled what? P. So these three elements we have here, they are what? Paramagnetic element. Because the three of them, they are partially feel what? P orbital. And the most transition element to other elements, they are paramagnetic elements, but their own is what? They are partially feel what? D orbital. When you get to transition element in periodic table, you will get that one right. So the last function of what? Or application of Ohm's rule is what? Ohm's rule is also used to determine the what? Diamagnetic element. The what? Magnetic element. What is diamagnetic element? They are elements that completely fill the what? The generate orbital, which is what? PDF. Are what? So neon is a good example of what? Of diamagnetic what? Element. Neon is a good example of what? Of diamagnetic what? Element. So you can use Ohm's rule to determine the three things. Number one, number of unpaired electrons in an atom. Number two, remember the word paramagnetic element. Any element that partially fill what? The generate orbitals are called paramagnetic elements. So we have, it can only use to determine the what? Diamagnetic element. The element that what? Completely fill the what? The generate orbitals. So that is all about what? Atomic theory. So in the next class, we are moved to the what? To the next chapter in chemistry. Thanks for watching.